Hey everyone, in this video we will study bearings and its types, different types of bearings. Now what bearing is? Now there is one rotating element like a shaft or a axle, and bending load is acting over that, and you need to provide a support to that shaft or axle. So how that support can be provided? Let us take an example of shaft. So you how to provide the support, but at the same time you have to permit the relative motion between that support and the shaft. So bearing does the same thing. So bearing provides a support. So it is a machine element which locates two machine parts and permits relative motion between them. That is called as bearing. What are the functions of bearing? It supports shaft and axle and holds it in a correct position with respect to the frame. It ensures free rotation between shaft and axle, and bearing takes up force from shaft and transmits it to the casing. It takes up the force from the shaft and transmits it to the casing. So these are the functions of bearing. What are the types of bearings? Depending upon the type of contact, whether it is a sliding contact or a rolling contact. So when you have sliding contact bearing, sliding contact between the two mating surfaces, those bearings are called as sliding contact bearing. And when you have rolling contact between the two mating surfaces, like suppose balls are used or rollers are used, they are called as rolling contact bearing. Sliding contact bearing is classified into the three categories. First is a guide bearing, journal bearing, and thrust bearing. Now we will see one by one. First sliding contact bearing, and then we will go for rolling contact bearing. So in a sliding contact bearing, what is that? The bearing in which contacting surface either makes sliding contact or separated by a film of lubricant are called as sliding contact bearings. And again, these are the three types: guide, journal, and thrust bearing. In a guide bearing, the motion between two mating surfaces is a linear. It is not a rotary. So when you have a linear motion between two mating surfaces, like a piston cylinder arrangement, or again one example can be given: guideways of the machine, guideway of lathe machine, the saddle, which is an edge-shape casting, is in contact with the guideways of the bed. So carriage slides over the guideways of the bed. So that is again one more example of guide bearing. So when you have relative motion, and that relative motion is a linear motion, those kind of bearings are called as guide bearings. Now what is journal bearing? In a journal bearing, you have relative motion between the two mating surfaces. So here you can see that, let me see the cursor. Yes, this is a shaft, rotating shaft, and it is supported by this bearing. So the relative motion between this shaft and this bearing is of a rotary type. It is not of a linear motion. There is no linear motion. It's a rotary motion. So as it is having a rotary motion between the two mating surfaces, this kind of bearings are called as journal bearing. Now we will see the types of journal bearings. So journal bearing, first type is a solid journal bearing, second is a bush bearing, and third is a split bearing. In a journal bearing, it consists of a block generally made up of cast iron with a hole for a shaft. Now, what is that word called as a journal? The shaft will rotate inside this bearing, and that rotating shaft is called as journal. So it consists of a block. Generally, this block is made up of the cast iron. And inside surface is made up of the bearing material. What are the bearing materials? They are brass, bronze, babbitt, or aluminum alloys can be used. Why these alloys are used and why this material is used? Because the material used for this inside surface, which will be in a contact with the shaft, should not be much harder. If it is much hard, then there will be a lot of friction and that leads to the more power loss. So that is why soft material is used for the this inside surface. Okay, so what are the disadvantages of the solid journal bearing? Shaft is in directly contact with this surface, so there will be a wear and tear. In due course of time, there will be a wear and tear, and if at all there is a wear and tear, you have to completely replace this bearing. You will have to completely replace this bearing, right? So that is the first disadvantage. And second disadvantage is you will have to place it endwise from one of the endwise or lengthwise. From one of the end, you have to place this. So these are the disadvantages. Now, how to cope up with that disadvantage, that will be covered in the next bearing. So here, that between the contacting surface, bushes are used. So a bush is used. So if the bush is used, that bearing is called as a bush bearing. So it is an improved version of solid journal bearing. Constructional features are almost the same, but here the part which comes in a contact with the shaft, there a bush is inserted. That bush is made of the material brass or the bronze, so that bush will be in contact with the rotating shaft. And now it is in contact with the rotating shaft, so there will be a wear and tear of the bush, so that bush can be easily replaced, right? Not whole bearing, so that will save the cost. But another problem still persists, and that problem is that you have to place this bearing endwise only. You have to place this bearing endwise only. So that leads to the less mechanical flexibility, right? So now this problem can be solved in the next type. There we have split journal bearing. So here you have divided this solid journal bearing into the two parts. It is an improved version of solid journal bearing. When the shaft is very long and is provided with a number of steps, then it is used. Means it is, if suppose it is not possible to place it endwise, then you have to go for split journal bearing. Now what are the thrust bearing? In this case, these bearings can only support, split journal bearing can only support the radial load. What is radial load? The load which acts perpendicular to the axis of shaft. But it cannot sustain any load that is acting along the axis of shaft. That when the load is acting along the axis of shaft, that is called as thrust load. So to support thrust load, we have thrust bearing. The bearing in which relative motion between them is rotary, while the pressure on the bearing is parallel to the axis of shaft. So when load is acting parallel to the axis of shaft, that kind of bearing is called as thrust bearing. So footstep bearing or a pivot bearing and collar bearing are the types. These are the applications of sliding contact bearing. Can be used as a crankshaft bearing in IC engine, steam and gas turbine, marine application, conveyors and centrifugal pumps. Now rolling contact bearing. What was the difficulty with sliding contact bearing? That there was a friction. Though you are using lubrication, but there can be a friction, and that leads to the power loss, right? So that surface contact, we will try to replace that surface contact by either point contact or line contact, and that can be done by using either ball or roller. So here the contacting surface is either ball or roller, and they will roll against each other. Mating surfaces will roll against each other, so that is why they are called as rolling contact bearings. So depending upon whether ball is used or roller is used, they are classified as ball bearing and roller bearing. So here you can see You have outer rest. This is a cross-sectional view of that outer rest that fits into the casing or a frame, so that force will be transferred to the that bending load will be transferred to the frame or casing. Next we have a roller. Next we have roller, and that roller is supported with the help of this part. This part is called as a retainer or a separator. Next, after that, we have inner rest, that is in a close contact with the rotating shaft. Again, parts are repeated as it is a cross-sectional view. So with the shaft, we have in contact with the shaft, you have inner rest. After that, separator, and inside the separator we have balls, and after that we have outer rest. So what is the function of this separator? To hold rollers and the balls at its correct position, and also to hold lubricant. That is the function of separator. Understood? Now we'll see ball bearing. In a ball bearing, again we have outer rest, balls are separated by this separator or a retainer. After that, inner rest, shaft, and again parts are repeated because it's a cross-sectional view. So ball bearing, in this rolling elements are spherical balls. The contact of a rolling element with the inner and outer rest is a point contact. Type of ball bearing: single row deep groove, double row deep groove, angular contact bearing, and thrust ball bearing. Now we will see one by one. In a single row deep groove, on an inner rest and outer rest, some grooves are created, right? So again, outer ring, ball, retainer, and inner rest. This idea will again get clear in this diagram. What outer ring is, outer rest is, ball is, retainer is, and inner rest is. Right. So what load they can sustain? They can sustain a load which is acting perpendicular to the axis of shaft, that is a radial load. And they can also sustain the some amount of axial load, that is a thrust load. Now these bearings, they have some single row deep groove ball bearing, they have some limitation with radial load as well as with the axial load. They can support moderate amount of load, but when load is increased, you have to go for a double row deep groove ball bearing, in which one of the row of the ball bearing will be added again, so that bearing can be used for higher amount of radial load as well as for higher for again to support axial load, that is a thrust load. Angular contact bearing, balls and grooves are created with some angle, and balls are also placed with some angle, so that they can support the load coming from in the direction of axis. Thrust ball bearing. In a thrust ball bearing, we have this outer ring. Inside that, one more ring is there, and balls are there placed in that ring. That ring holds the ball in between, and after that, at the bottom you have this lower ring. So that ring which holds the ball is placed between these two rings, so that it can sustain the load which is acting parallel to the axis of shaft. Its best example is in the wheelchair, rotating wheelchair, rolling chair. Then next is when load is again increased, we have to increase the contacting surface. So the balls will be replaced by the rollers. So in this bearing, rolling elements are cylindrical and they are rollers. So contact between roller and inner surface is a line contact. So again, there are different types: cylindrical, needle taper, and taper thrust bearing. So this is a cylindrical roller bearing. Needle bearing, when there is a radial space limitation, we can go for a needle bearing. And taper roller bearing, when you have to support axial load as well as radial load. So radial load and axial load you want to support, then you can go for taper roller bearing. This is how the different bearings are and different types of bearings. Thank you very much for listening.